In this lesson, I will discuss the angles of elevation and depression. And this is the application of using the basic trigonometric ratio to solve real-life questions that is arising from our basic right-angled triangle shapes. This man is looking up to this airplane. So the line of sight is the blue. And the angle that the line of sight makes with this horizontal line, that is the angle of elevation. Whereas the angle of depression is the angle that the line of sight makes with the horizontal line when we are looking down to an object. So angle of elevation is when we are looking up, angle of depression is when we are looking down to an object. So for question number 1, we are given that a ladder is 15 feet long and the ladder is resting against the side of the house, and the angle of elevation that the ladder makes is 80 degrees. So we are asked to find the height from the top of the ladder to the ground. So these are simple right angle triangle. I can redraw this shape like this. Okay. So we have that's our right angle. This is the angle of elevation, which is 80 degrees in this case. And this is the hypotenuse, which is 15 feet. We are looking for the side that is opposite to the angle of elevation. To remind you about our basic trigonometric ratios, so whenever we have the opposite and hypotenuse, that's the sign should come to your mind. So it is so, ka, tua. So in this case, we are going to apply the so. So that means the sine of 80 degrees will be equals to the opposite, which is h in this case, divided by hypotenuse. So and here the hypotenuse is 15. So it is easy to cross multiply. This will give our h to be 15 multiplied by sine 80 degrees. And if you use your calculator, that comes down to 14.8 feet. So the height from the top of the ladder to the ground is 14.8 feet. So this second example, it appears that we are at the amusement park. So the roller coaster is 60 yards from the ground. So you can see that the roller coaster is 60 yards from the ground. So a rider that is on the top of the roller coaster is looking down to this merry-go-round and also looking down to the Ferris wheel. Okay, so the angle of depression that the rider's line of sight makes with the merry-go-round is 11 degrees, and the angle of depression that the rider's line of sight makes with the Ferris wheel is 8 degrees. So we are now asked to find the distance of the rider to the merry-go-round and the distance of the rider to the Ferris wheel. So if you have a question like this, you might want to redraw it. So for me, I decided to draw the question so that I can see it. So we see that this merry-go-round makes a right angle triangle with the horizontal line, okay? And this angle is 8 degrees, okay? And this one is 11 degrees. So we are looking for the distance of the rider to the merry-go-round, okay? So this is the merry-go-round, okay? So we are looking for this distance A, and then we are looking for this distance B, okay? Which is the distance to the Ferris wheel. So we are looking for two distances. As you can see, we are dealing with two separate right angle triangle in this question. So the first one is the smaller right angle triangle made by the line of sight of the rider with the merry-go-round. So if this is 60 yards, this is also going to be 60 yards. So what do we know? We know this height, which is directly opposite the angle, so that is the opposite. And then we are now looking for the hypotenuse. So I'm going to use the sine. So sine SOHCAHTOA, sine of the first one, 11 degrees, would be opposite. So which is 60 yards divided by my hypotenuse A. Okay, so the A again is the distance from the rider to the merry-go-round. So A will now be, if I cross multiply, will be 60 divided by sine of 11 degrees. And if you put that into your calculator, you can see that A will be 314 yards. The rider is 314 yards from the merry-go-round. The second question asks us, how far is the rider from the Ferris wheel? So we are now considering this second right-angled triangle in this case. Okay, I'm just highlighting so that you don't get confused. And we know that, okay, the angle of depression is 8 degrees, and this vertical distance is still the same thing as this. So this is also 60 yards. So I'm looking for this B. So I'm still looking for the hypotenuse. So I'm going to do sine of 8 degrees equals to opposite is 60 divided by B. So B again will be 60 divided by sine of 8 degrees. And if you put that into your calculator, you will see that B equals to 431 yards. So the rider is 431 yards from the Ferris wheel. So the third question says, a radio tower is located 400 feet from a building. So I'm showing you the building. So a radio tower is 400 feet. So let's show the radio tower is 400 feet from the building. And from a window in the building, a person determines that the angle of elevation to the top of the tower is 36 degrees. And the angle of depression to the bottom of the tower is 23 degrees. So we are told that the angle of elevation of the window is 36 degrees. So this is 36 degrees. And then the angle of depression is 23 degrees. So we are now asked to find the height of the tower. So let's call that H. So we are looking for H. So again, in this question, we are dealing with two separate right-angled triangle. So the first one is the one involving the angle of elevation. Okay. So let's call this height. Let's call it A. Okay. And then the second one is this angle of depression. Let's call this height. Let's call it B. So that means our H will be A plus B. Okay. We need to break it down like that. So I need to find first A and then find B. Then I need to add them together to be able to get the height of the tower. We are only given this adjacent distance, which is 400 feet. So I have adjacent and opposite. So then TOA should come to your mind. TOA, SOHCAHTOA. So let's apply the TOA in this case. The tan of 36 degrees will be opposite, which will be A in this case, divided by the adjacent, which is 400. Okay, so A will be 400 tan 36 degrees. So if you put that into your calculator, you will see that A will be 290.62 feet. Let's find B. We have opposites and then we have the adjacent. Using TOA again, tan 23 degrees will be equals to opposite, which is B in this case, divided by adjacent, which is 400. So B will be 400 tan 23 degrees. So if you use your calculator to simplify that, so B will give you 169.79 feet. So now the height of the tower will be A plus B. So if you put that into your calculator, you will see that, so this will be 290.62 plus 169.79. So you are going to be able to get 460.4 feet. So, and this is the height of the tower. So the height of the tower is 460.4 feet. So I hope you understand angle of elevation and depression. I knowingly picked these questions, but I hope you can be able to walk through any question that is given to you. So thank you so much. Please subscribe to this channel.